So here's page 3 of Applications of Integration, HL Addendum. Number 10, find the volume of revolution when the following regions are revolved through 2 pi around the x-axis. So here, the only thing different about this one than problems you've done in the past is it's a secant function, and we don't see that too often. The secant function is the reciprocal of the cosine function. So remember, cosine kind of starts here and it goes down. So secant function starts here and goes up, right? And so basically we're going to take that shape, which kind of looks like this, one, and we're going to go from 0 to pi over 12, and we're going to rotate that around the x-axis. So it's going to look kind of like this. And we're going to cut it into cylinders like that. And so basically it's going to be an integral from 0 to pi over 12 of the function secant 3x dx. Oops, nope, not that quick. Okay. So secant 3x squared, because it's going to be pi r squared. And then the thickness of each disk is dy. And so when we take the derivative of this, the derivative of secant squared, that sounds familiar, or the integral of secant squared. The integral of secant squared is something like tangent, because the derivative of tangent is secant squared, right? Now, of course, this one is a little bit different. It's got a 3 here. So we do need to do kind of like an inverse chain rule or U substitution or something. Oh, sorry, it's not dy here, it's dx, right? Okay, sorry about that. So, let's go ahead and guess our integral. I'm going to say it's like tangent 3x pi, and I'm going to divide by 3, something like that. Let's see if that works. So, I'm going to test, I'm going to do, I'm going to take the derivative of tangent 3x. That would give me pi over 3 secant 3x squared, and then I'm going to do the chain rule on 3x. I'll get 3, and then the 3's cancel out, and hey, that's exactly what I should have gotten, so it's fine. Okay, so now I'm going to actually do the substitutions of the limits of integration. So the first one would be pi over 3 tangent of 3/12 pi. And 3/12 pi, that's equal to 1/4 pi, pi over 4. Tangent of pi over 4 is 1. So this whole term here just becomes pi over 3 times 1, so it's pi over 3, right? And if I subtract pi tangent of 0, not tangent, right? Tangent of pi tangent of 0 divided by 3, tangent of 0 is just 0, so this whole thing becomes 0. So basically, the answer is pi over 3. So sketch the graph of y equals 4 sine 2x for 0 to pi over 4. And then find the volume of revolution of the shape bounded by the function, the x-axis, x equals 0 and x equals pi over 4, when it is rotated through 2 pi about the x-axis. Okay, so this graph here is just a regular sine function, and it is quite narrow. It's twice as narrow as normal. So instead of going from 0 to 2 pi, this sine function goes from 0 to pi. And so basically, in the domain 0 to pi over 4, it will complete 1/4 of a cycle. So basically that would look kind of like that, right? So it is 4 high because the a value is 4, and the x value here is pi over 4. And we are going to rotate it around the x-axis. So basically that would look kind of like this. Okay. So let's write the integral for that. It's going from 0 to pi over 4. The function is 4 sine of 2x dx. And, oops, this is a solid of revolution, so this is going to be pi r squared, so we're going to put pi and then r squared dx. Okay. And so, let's see, this is going to look like a function that maybe is not easy to integrate. It'll be 16 sine squared 2x. Put a pi here too. And remember that if you have a sine squared, that's not something that you're going to be able to integrate without doing a trig substitution. And the trig substitution you're going to do is going to be related to the double angle formula. So remember, cosine 2 theta equals cosine squared, 2 cosine squared theta minus 1, or cosine 2 theta is 1 minus 2 sine squared theta. This is on your formula sheet. Now the form that we need it to be in is we need to isolate the sine squared. See, there's a sine squared there. Ignore the fact that it's a 2x, okay? Pretend the 2x is theta. Let me just rearrange this here. So it's 2 sine squared theta equals cosine 2 theta minus 1. No, wait. 1 minus cosine 2 theta. Right? And so instead of theta, I'm going to put 2x, right? And if this is 2x, then 2 theta would be 4x. Now the last step, notice that the pink part that I need to substitute is sine squared 2x, not 2 sine squared 2x. So let's divide both the left side and the right side by 2. So basically I have sine squared 2x is equal to 1/2 minus 1/2 cosine 4x. Okay, so that is my substitution that I'm going to do. Let me just move this to the side. And so basically I'm going to have the integral of pi 16 times 1/2 minus 1/2 cosine 4x dx. And of course the limits of integration are as they were. And now I'm going to, let's see, I'm going to simplify the coefficients a little bit. It'll be pi times 8 minus pi times 8 cosine of 4x. And I'm going to take the integral of that. Okay? So the integral of 8 pi is 8 pi x. And the integral of 8 pi cosine 4x is 8 pi sine of 4x. And then I'm going to take the integral from 0 to pi over 4. And first I'm going to substitute in pi over 4 into each one of these. So pi over 4 into this is going to be 8 pi times pi over 4. That's going to be 2 pi squared. And then I'm going to put in pi over 4 here. Sine of 4 times pi over 4 is actually sine of pi. Sine of pi is 0, so that's just going to be 0. And then I'm going to substitute 0 in for each one. The first term, of course, is going to be 0. The second term is sine of 0, and that's also 0, so that's also going to give me 0. So basically the answer is 2 pi squared. (22e.2). We're going to do some new kind of problems where basically we got revolution like before, except for there's like another shape drilled out of the center of it. So basically we can define two functions. We can define the g function, which defines the inner boundary, and the f function, which defines the outer boundary. And we're going to take both the inner boundary and the outer boundary, and we're going to spin it around the x-axis, and we're going to make function that's hollow, and the equation which we use to do that is we take the integral from the limits along the x-axis, a and b, and we're going to do a pi r squared, but instead of a regular pi r squared, we're going to have 2 pi r squared, we're going to have an outside pi r squared, and we're going to subtract the inside pi r squared. The outside pi r squared is going to be defined by the function f, like here, and the inside pi r squared is going to be defined by the g of x function squared. Okay, so let's try to do an example. So the region we're going to rotate is y equals 4 minus x squared, which is this upside down parabola, and y equals 3, which is this straight line here. And basically that forms this little chord here. It's a chord looking thing. And if you rotate this chord looking thing around the x-axis, you can see that you're going to get kind of like a wedding ring or something. It's kind of round on the outside, flat on the inside. And it's hollow like a ring, right? So the first thing this asks is, what are the coordinates of intersection between the parabola and the straight line? We can find that pretty easily by substituting y equals 3 into here and finding out what the x value is that corresponds to y equals 3. When we do that, we find out x squared equals 1. X squared equals 1, the solution for x is plus or minus 1. So, and then we want to find out what the y value is that corresponds to plus or minus 1. Of course, it's always 3 because y is always equal to 3 for one of the functions. So the two solutions are 1, 3 and negative 1, 3. Those are the coordinates for a and b. This, of course, is negative 1, 3. This, of course, is 1, 3. Then it says to find the volume of the revolution. Let's fill in the formula from above. So we're going to do an integral from negative 1 to positive 1, and we're going to have f of x, the outer function, 4 minus x squared. We're going to square that, and we're going to subtract the inside function, which is y equals 3, square that, and then take the integral of that. So looks like in order to have a chance of integrating this, we're going to need to expand it with FOIL. So we'll have pi times the integral from negative 1 to 1 of 16 minus 8x squared plus x to the 4th minus 9. And if I did 16 minus 9, it would be 7 minus 8x squared plus x to the 4th. And then we're going to take the integral of these terms. So it would be 7x minus 8x cubed divided by 3 plus x to the 5th divided by 5. And we're going to integrate from negative 1 to 1. And let's substitute in 1 for each thing. So it would be pi 7 minus 8/3 plus 1/5 minus, and then I'm going to substitute negative 1, so negative 7 minus 8 times negative 1 cubed is going to be positive 8/3 minus 1/5. And so this is all multiplied times pi. And so basically, I'm going to add these two terms together. I'm going to get 7 minus negative 7, so that's be 14. And then I'm going to do these two terms, minus 8/3. Minus 8/3 is minus 16/3. And then I'm going to do these two terms, 1/5 minus negative 5th is 2/5. Okay, and then let's see, I'm going to put everything over a common denominator of 15. So it'll be, let's see, 15 times 14, that's a big number. That would be 210. And then to change 16/3 into something over 15, I would multiply both the top and bottom by 15. 16 minus 5 is 80. And 3 times 5 is 15. And then 2/5 times times 3 on top and 3 on the bottom would be 6 on top, 15 on the bottom. And then I'm going to combine the numbers on top. 210 minus 80 is 130. Plus 6 is 136. So my answer is going to be pi times 136 divided by 50.